My dear friends, first of all, I wish a good day, good morning, good afternoon, good night. Okay. You know, this very important article in your syllabus. What is that? Yes, that is moving coil galvanometer. So in order to understand moving coil galvanometer, first of all, we have to go through the two sub-articles. Number one, force acting on current carrying conductor in a magnetic field. Number two, force or the torque acting on a current carrying coil in the magnetic field. So before going to moving coil galvanometer, I am going to explain the force on a current carrying conductor first, second the torque on a current carrying loop. तो मेरे दोस्तों, मैं मूविंग कॉइल गैल्वेनोमीटर जो कि आपको एग्ज़ाम में 100% आने के चांसेस हैं वो एक्सप्लेन करूं, तो मैं दो आर्टिकल आपको बताने जा रहा हूँ। तो एक कंडक्टर है जिसमें करंट चल रहा है, उसको फील्ड में रखा है, तो क्या होगा, कितनी फोर्स लगेगी। दूसरा, एक कॉइल है, उसमें से करंट पास किया है, तो उस पर टॉर्क कितना लगेगा, तो मैं डिस्कस करने जा रहा हूँ। एक बात और, +1 +2 मीन 11th 12th, any difficulty, any topic, if you are having, don't hesitate. Please write me in the comments box, or you can call me, or you can send a message to me. My WhatsApp number is 9888 169 226. And one thing more, if you find this video is helpful to you, please subscribe my channel as well as like it also. Thank you very much. So my article is talk on a current loop in a magnetic field. First of all, what we mean by current loop? करंट लूप का मायना क्या होता है? कुछ नहीं होता, सिंपल सा है। देखो, आप ना एक फ्रेम ले लो, ये फ्रेम ना हॉलो है इन साइड से, जैसे फोटो फ्रेम होता है, पर अंदर से खाली होगा। तो आप एक वायर ले लो, वायर को ऐसे ऐसे करते जाओ, तो ऐसे ऐसे करते जाओगे तो क्या बनेगी, ये लूप बन जाएगी। इसमें से आप करंट पास कर दो, करंट यहाँ से जाएगा, यहाँ से बाहर आ जाएगा। दिस इज अ करंट लूप, लाइक आई एम हैविंग दिस करंट, दिस इज अ लूप, नो करंट इज फ्लोइंग नाउ बट इट इज अ लूप। कि इसकी काफ़ी थिकनेस है, पर जो मैं कंसिडर करने जा रहा हूँ इन माई आर्टिकल, द करंट लूप वेरी वेरी स्मॉल थिकनेस, but there are number of turns. ऐसी लूप मैं अज्यूम कर लेता हूँ कि ये मैंने ना ऐसा, ये एक फ्रेम है, अंदर से ये फील्ड है, बट मेरा फ्रेम क्या होगा, अंदर से हॉलो, और उसके ऊपर क्या होगा, वायर। उसके ऊपर क्या हुआ है, उसके ऊपर एक वायर है, ठीक है। उसको वो क्या हो गया, वो हो गया हमारे पास लूप बन गया, वायर लूप, ठीक है। तो मैंने क्या करना है, व्हाट आई एम डूइंग नाउ, मैंने ये जैसे ये लूप है, A B C D, this is loop like this. This is A, B, C, D. अंदर से होलो है, याद रखना, और कॉपर वायर है, ऐसे इंसुलेटेड है कॉपर वायर। वो वायर एक दूसरे से टच कर रही हैं, बट इलेक्ट्रिकली कनेक्टेड नहीं है। टच करेंगी, जुड़ेंगी, पर इलेक्ट्रिकली वो नहीं जुड़ेंगी, उस पर इंसुलेशन हुई होती है ना, इंसुलेटेड कॉपर वायर। तो ये बन गई लूप। अब मैं ले रहा हूँ मैग्नेटिक फील्ड। मैग्नेटिक फील्ड मेरी ना ऐसे है, ठीक है, इस डायरेक्शन में, पेन की डायरेक्शन में, और ये लूप है। अब लूप को मैं रोटेट कर सकता हूँ, ऐसे मैं रोटेट कर सकता हूँ, ऐसे, ठीक है। तो रोटेट करने से पहले मेरे पास ना ये पोजीशन है, इसको मैं बोलूँगा, इस साइड को, ये साइड क्या है, ए बी। ए बी जो है इस वक्त परपेंडिकुलर है ना, ए बी इस वक्त परपेंडिकुलर है। जब ये रोटेट करेगी, जैसे सपोज मैं, चलो ऐसे रोटेट कराता हूँ, ऐसे रोटेट हो गई, तो मुझे बताओ व्हाट इज द एंगल बिटवीन मैग्नेटिक फील्ड एंड लेंथ? इट इज स्टिल 90 डिग्री, यू नो, देखो इट इज स्टिल 90 डिग्री, है ना, और ये ऐसे रोटेट हो गई। नाउ दिस एंगल इज स्टिल 90 डिग्री, समझ आ रही ना, इसमें और मैग्नेटिक फील्ड में स्टिल एंगल 90 डिग्री। तो इसको कैसे भी रोटेट करा लो, ये एंगल मतलब ये साइड जो है और ये जो साइड है, इसका एंगल विद मैग्नेटिक फील्ड इट ऑलवेज रिमेन्स 90 डिग्री। ऐसे रोटेट हो रही है, बट दिस एंगल, यू नो, दिस एंगल रिमेन 90 डिग्री। ये एंगल हमेशा 90 का ही रहेगा, ओके। बट ये जो है ना ऊपर वाली साइड, दिस इज कॉल्ड ब्रेड्थ ऑफ द कॉइल। ब्रेड्थ ऑफ कॉइल में और मैग्नेटिक फील्ड में व्हाट इज एंगल? 0। अब द एंगल बिटवीन दिस एंड ब्रेड्थ is increasing, it is 90 degree, and you know, still it is increasing and becomes 180 degree. So starting from 0, this angle increases, breadth and magnetic field, and goes to 90. Okay, breadth का एंगल चेंज होगा, पर लेंथ और फील्ड में एंगल, इसमें और मैग्नेटिक फील्ड में एंगल 90 ही रहेगा। दिस इज वेरी 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 इंपॉर्टेंट, गेटिंग माई पॉइंट। इसमें एंगल चेंज होगा विद ब्रेड्थ, इसमें नहीं चेंज होगा लेंथ में, ठीक है, समझ गए ना? ओके, नाउ कमिंग हियर। तो ये क्या है? लेंथ। ये क्या मैग्नेटिक फील्ड? तो 90 का एंगल होगा। तो अभी हम क्या कह रहे हैं कि इफ देर इज दिस इज अ करंट कैरिंग कंडक्टर एंड इफ इट इज प्लेस्ड इन अ मैग्नेटिक फील्ड, देन दिस लेंथ कैरिंग कंडक्टर विल एक्सपीरियंस अ फोर्स। तो इसको फोर्स लगेगी, है ना? फोर्स किस डायरेक्शन में लगेगी? बिकॉज इफ देयर टू आर इन द प्लेन ऑफ पेपर, तो F इक्वल्स टू I into L cross P, mean perpendicular to the plane in which L and B lies, mean along this direction it will experience a force. इतनी फोर्स लगेगी, okay? Now coming here, this is a length and this is a magnetic field. So this is a length, okay, and current is flowing like this. Apply the Fleming left hand rule. ये फिंगर ऐसे करोगे आप, है ना, ये फिंगर करंट ऐसे करोगे, थंब मतलब आपकी तरफ फोर्स आएगी along your direction, outward, plane of paper and outward, magnetic field, current and outward. So this force FAB, AB mean this length AB. A to B, it will, इस पे फोर्स लगेगी कितनी, F1 mean like this, outward. So this is outward. Similarly, what is the difference between AB and CD? Only the difference of current. This current is downward, this current is upward. So again apply the Fleming left hand rule here. If this force is outward, because the current is opposite, this force will be inward. So this F2 means force on CD. So this F2 is inward. There is F1, there is F2. Both are equal in magnitude. And how much? F equals to, because I into L cross B. And what is the angle between the two? I just explained. This angle always remains 90 degree between L and B. So ILB sine 90 always remain 90. Sine 91. So F equals to ILB. So this side will experience ILB. This side will experience ILB. Equal forces but opposite in directions. Now coming, and these two forces, they will constitute a torque. Why? Because what is the distance between these two forces? This distance is equals to the breadth, this line AD. So this is this is line AD. Okay, so one force is like this, other force is like this. Equal and opposite forces, how much? Equals to ILB, IL. Now what is the torque? Torque is force into perpendicular distance between the two forces. What is perpendicular distance between the two forces? Perpendicular distance between the two forces. That distance is, this is this distance. This is the distance between this force and this force. Now if this is B, okay, and if I say this angle is theta, this angle is theta, what will be this? This becomes a base, okay, this becomes perpendicular. It is B sine theta. B is the breadth, right? So this becomes P sine theta, this much. Remember what is angle theta? Theta is between breadth and this one. Now again, there's a very important point. Now the important point is, direction of the magnetic field. Direction of the magnetic field was like this. This was magnetic field. Okay, and this is, the plane of coil. This is the plane of coil. Plane of coil is making an angle phi. This is plane of the coil. This is magnetic field. Now this line is normal to the plane of coil and it is called area vector. Between area vector and magnetic field, the angle is theta. Okay, Now theta plus phi equals to 90 degree. Now coming here, if this angle is phi, this angle will be phi, this one, okay. If this angle is phi, this angle is 90 degree, then what would be this angle? Okay, this angle is phi, this angle is 90, this angle will be 90 minus phi. What is 90 minus phi? So here theta equals to 90 minus phi. So I proved that this angle is theta. Remember, this angle is theta. So theta is actually between area vector and magnetic field vector. Don't confuse, there are two angles. One is phi, between magnetic field and the plane of coil. Other is theta, between area vector and magnetic field. If this angle is theta, I proved this angle is also theta. Because this is phi, this will be phi, this is 90. This will be then 90 minus phi. 90 minus phi means theta. Okay, now you consider this right angle triangle. This perpendicular comes out equals to, if this is B, this is theta, so this becomes B sine theta. Now what is the torque? What is torque? Torque is force ILP into perpendicular distance, this one, B sine theta. Okay. Now length into breadth is area of the coil. I, length into breadth, is capital E, B sine theta. Now this is the expression if you are having only one turn. If your coil having n turns, this becomes Ni AB sine theta. Okay. Now, you know well, this can be written as I N A. Okay. Now current into area is what? Magnetic moment. Current into area is magnetic moment. Number of turns are n. So total magnetic moment is capital M, MB sine theta. Well, I replaced NIA with capital M, magnetic moment of the coil. So torque is a vector quantity, M vector cross B vector. So this is the value of the torque acting on a current carrying coil. Depends upon the angle theta. Okay. Now coming here. Now I explained that these two forces, they are constituting a torque because there is some perpendicular distance like this one. But you may ask a question, what happened to the force on AD and force on AC? No problem. The current flowing in AD, it is like this. It is also in a magnetic field B. So apply this formula, I into L cross B. B is the breadth. You will find a force, this side will also experience a force along this direction, perpendicular to the plane in which it is a breadth and the magnetic field. And this is B vector, breadth vector. This is capital B vector. So move the screw like this, you will find it is upward. Similarly, this side will experience a force downward. Why downward? Because here current is like this, here current is opposite. Current is opposite, so force becomes reversed. Now this side experience a force, this side experience a force. But your question will be, why not they are constituting a torque? There are the two forces. Why not there is a torque? Because these two forces, there is no perpendicular distance. They are acting along the same line. Along the same line they are acting. Perpendicular distance is 0 between the two forces. If there is one force pulling it like this, other force pulling is like this, so the action becomes 0. And no perpendicular distance between the two forces. So no torque because of the these two forces. Torque will be because of this and this. And for this line and for this line, angle remain 90 degree. So that force in magnitude remain equals to how much? ILB, IL. Force remain equals to ILB. Okay, and force into the perpendicular distance, which is B sine theta, becomes the torque. If there is one turn and length into breadth becomes area, then multiply with N, total torque. So that's very simple. Torque will be perpendicular. Now I am lastly going to explain the direction of the torque. Okay, now coming here. Now will you tell me what is the angle? There are two angles. I explained here. There are two angles. One is, there are two angles. One is angle phi between the plane of coil and magnetic field. Other is angle theta between magnetic field and the area vector. Okay. Now tell me here. Now this is a position. What is theta and what is phi? Okay, what is phi? This is plane of coil, this is magnetic field. So there is no angle. Mean here phi equals to 0. And what is between magnetic field and area vector is like this. Area vector will be like this. This is area vector perpendicular to plane. And this is magnetic field. So between magnetic field and area vector, angle is theta is 90 degree. Theta is 90 degree and alpha equals to 0. Also, alpha plus theta equals to 90 degree. If alpha equals to 0, theta is 90. So what is the torque now in this case? Because theta is 90 degree and torque is sine 90 maximum. So in this case, the torque will be maximum torque, this case. Now coming to this case. Now you tell me what is angle phi. This is magnetic field, this is the plane of the coil, this is the plane, and this is magnetic field. So between plane, this is plane, okay, and this is magnetic field. Now phi equals to 90. If y equals to 90, what is theta? Theta area vector is like this. This is area vector. And magnetic field is also like this. So magnetic field and area vector both are along the same direction. So theta equals to 0. So theta 0 here, torque becomes 0. So no, there is no torque. So if this is the position of the coil, it will not experience any torque. If this is the position, it will experience maximum torque. So if the coil rotates, let maximum torque, coil rotates. Torque decreases, becomes 0.